you, everyone, for coming and hanging out with us. My name is David Tischler. I run a small server hosting company by the name of miniNodes, miniNodes.com, and I typically
put the microphone up closer.
Oh, sorry. And I typically use that mostly as a platform to evangelize ARM technologies and interact with the community and engage with other folks using ARM in IoT, edge, and server infrastructure use cases. Carl,
cool. And my name is Carl Perry. I work for Packet as my day job. We do bare metal hosting on x86 and ARM and hopefully soon other fun architectures. We also help run a project called Works on ARM with ARM. Because we got to say ARM every other word, that's how I get paid. The Works on ARM project basically allows us to get hardware in the hands of developers who want to make sure that their software is actually working on it without having to go out and buy really expensive things. We have really big boxes with decent amounts of memory and good connectivity and fun stuff like that. And we do all that for community efforts. And then by night, I help out David with miniNodes and do some other fun stuff as well. So, and also hack on ARM boards, which is what we're here to talk about today.
That's correct. All right, so let's take a look. All right, so for the past, I'd say, year to maybe 18 months, I have seen in my social media feeds over and over and over the edge, the cloud, the intersection of the edge and the cloud, IoT, the IoT edge cloud. I just continue to see
the far edge.
The far edge. I continue to see people talking about this theoretical and mythical interactive environment from IoT to edge to cloud, but I had yet to actually see one built. I have not seen a functional system that incorporates all three layers. And that's not to say that they're not out there. They may very well be out there already, and I'm just not aware of them. But I figured, all right, everybody is talking about it, and no one is actually doing it, so I am going to go about building this mythical IoT edge cloud system.
And then he suckered me into it.
And then I talked Carl into helping, which I'm surprised he said yes. So
this is kind of our architecture. We have a map that we will show in a minute that actually shows where all of this stuff is. But we have at the very top is a cloud server. It's an Ampere eMAG box. It's sitting in Packet's data center in Newark. We have running on that the visualization software and the data storage, which is InfluxDB and Grafana. We have two edge nodes, one of which is reachable. That one is in his office in Arizona. It's running on a 96 board Heike 960. And then we also have one in India. Fun fact, all of India is IPv4 NATed, so we can't actually talk to it. So we spent some time trying to figure out how we were going to work around that, and then it eventually just went, I think we're going to move that node somewhere else so that it can actually be talked to, and we'll go from there. We'd love to make it work on IPv6, but the issue becomes the rest of the world isn't IPv6 enabled, mostly the United States. So that becomes problematic for actually trying to talk to that edge node over IPv6 as well. So fun and exciting stuff. And then we have the IoT endpoints, which I am going to pass this around. So this is one of our endpoints. It is a feel free to look at it and poke at it. It is a Raspberry Pi. We've got a couple of sensors plugged into it. We have a lightning sensor from SparkFun. So this will actually tell you how far away a lightning strike is and what kind of lightning strike it is. We have an environmental sensor that will do temperature, barometric pressure, humidity, volatile organic compounds in the atmosphere, so we get some idea of air quality.
That's particulates.
Yep. And then also a GPS sensor so that we can pretend to have some idea of where it is. This was another.
I'm going to show you that we're not pretending anymore.
We're not pretending anymore, but it's exciting. So we just talked about this. Those systems are running Arm's Mbed Linux OS, and it's all being managed through Pelion. So this allows us to deploy applications or containers to it. Mbed Linux OS is still in pre-release. It's a technology preview. There are some rough edges. We ran into a lot of them. We're going to talk about that.
We'll discuss those later.
We'll get there.
In the presentation.
But it is a fairly nice system for actually being able to take all of the nodes, have them be managed in one way. We can push out stuff, do some configuration management with it, and various other odds and ends. This is what the dashboard looks like. Yeah. And yes, these are all of our nodes. We have a fair number of them. The hardware is basically identical on all of them. They're all Raspberry Pis. Why we went with Raspberry Pis is a question that I get a lot, and the answer to that is they're cheap. We could have done this with just regular Arm Mbed, but the issue that we ran into with that is most of the devices when we were starting this project that were on the supported hardware list were evaluation kits, so we could not buy large quantities of them. And for hardware manufacturers, large quantities is greater than like 4. And even if we did, they were expensive. Like I said, the Raspberry Pi was $35. With all the sensors, it was less than $100. Yeah, most of the boards that we were able to at least find a part number for were north of 200. And like I said, they were development kits, so it was a little bit harder.
The other thing about standard Embed is it's targeted more at the microcontroller space, so there's a lot of
a whole bunch of other problems in terms of connectivity of how do you get Wi-Fi, can you get Wi-Fi, can you get Ethernet, all of that fun stuff. If the box doesn't make it to you, that's kind of what it looks like. There's a couple extra wires. It turns out for the lightning sensor to function, it triggers an interrupt pin, so that needs to be tied into GPIO, so that's just kind of hanging there with some nice alligator clips. It's a proof of concept, so we weren't really excited.
Yeah, it doesn't need to be pretty.
Doesn't need to be pretty. Here is the beautiful map. So every one of the dots, sans the purple one, we have a sensor at. And I do want to make one note. The mapping tool that we use to make this has a strained definition of how pins work. Where the point of the pin is not actually where the device is, it's where the dot in the pin is. So just look a little bit farther north. We don't actually have one in Mexico.
Or the Atlantic Ocean.
Or the Atlantic Ocean, yes. So the purple one is the server in Newark. The red ones are where we have edge nodes and IoT nodes, and the green ones are just IoT nodes. We basically just called everyone we knew and said, hey, we're going to send you a Raspberry Pi. Please plug it in. And for the most part, that worked.
We've got a question?
Yes.
The one that's in Newark, are you sure it's still there?
Yes.
Yes. The Newark location is still online.
My phone would be ringing off the hook if it wasn't. It's okay. So we talked a little bit about the things that we are doing. So this is the stuff that we can currently do with this sensor. We're using the SparkFun Quick sensor system for interconnects. So that gives you 3.3 volts and I2C. Any sensor.
Quick connection.
Right. This is
plug and play.
Also compatible with Adafruit's Stemma ST. If you are in the Adafruit ecosystem, you can get sensors from there as well. And here are some other sensors that you can pick up in that particular user space. There's a whole bunch of neat stuff. We picked some stuff that would be interesting and then kind of went from there.
Yeah, in a moment, we'll see why we chose what we chose. Based on the sensors that you select, because they are essentially plug and play, we're going to walk through an example use case in a moment, but obviously something like this, it's cheap enough. Sustainability, environmental, manufacturing, retail, energy, all your standard IoT, environmental or IoT ecosystem targets are totally applicable.
Yep.
And apologize as I step over. So an example use case, what actually got me thinking about this problem and why we selected the sensors we did is this. Now, I'm looking around. I I know that Lenaro Connect is a very international event, and I'm sure that many of you have traveled from literally around the world.
Because we did it 6 months ago.
Yeah, yeah. So here we are in San Diego, California. I actually did not have to travel too far. I live in Phoenix, Arizona. And for those of you who are from the southwestern United States or are based in the United States and know what happens in the summer in the southwestern United States.
It gets hot. It gets real hot.
We've got extreme temperatures. So this is Arizona. This is where I live. Okay, that's the Grand Canyon, and those are the very stereotypical saguaro cactus. They're all over Phoenix. What else happens in the southwestern United States during the summer are wildfires, and they are massive. If they are left uncontrolled or they're not found quickly and put out quickly, they literally grow to hundreds of miles in diameter.
The other thing to point out is that most people's vision of the desert in the southwest United States has been provided by Warner Brothers Animation for the last about 40 years. There's a road, there's sand on either side, occasionally there's a road runner and a coyote following them, and maybe a tumbleweed. The reality of the situation is there's scrub brush everywhere. There's all sorts of small, lightweight stuff that if you give it a spark, it's going to catch on fire. Which is exactly what happened to David.
Exactly what happened. So, on the previous slide, there was a newspaper clip about a fire that was on Joe Max Road. Okay, fine. Nothing special about that, except I live on Joe Max Road. This fire was literally less than a half of a mile away from me. So these are some pictures that I took myself with my ARM-powered smartphone. That road is the road across the street from me at the top left, and that's another shot. Now, I actually do live on a paved road. Mine is actually paved, so that's nice, but the one across the street is not. There are people that live down that road. And also nearby is an RC air park. People go out there with their model airplanes and fly their model airplanes around. It's got a runway, it's got little hangars. It's a pretty neat little setup. It's an expensive hobby, but it's neat. Well, somebody is not the best pilot and crashed their model airplane. And when they crashed their model airplane, which was gas-powered, into this environment, it very quickly spread into a gigantic fire threatening other homes. There's farms out there, ranchers, livestock. It becomes a problem really, really quickly. So here's some of the aftermath. Literally along the side of the road, I stopped. I almost caused an accident as I pulled over the car and snapped some pictures. Probably wasn't the best idea, but
the important thing to note,
a real thing.
Time from crash to that happening was hours, and we're talking 3.
Yep.
And it was how many hundreds of acres?
Ended up about 1,100 acres,
Yeah.
And that was only because there happened to be a paved road that cuts east-west that acted as a break.
So the point is, we were like, hey, wouldn't it be cool if we could have sensors around to kind of detect this stuff and report it back to the appropriate authorities? So that was part of it. We've also had some discussions with some folks of like, hey, wouldn't it be neat if we could put like some of those environmental sensors and kind of litter them all over the place and be able to do data collection at a micro level to help feed into larger climate models. That's another potential use case as well. There's some connectivity issues there, so there's some power issues there. Raspberry Pi is probably not the best thing to do, but there's definitely stuff that can be done. So it all makes sense. So heading back to our endpoint, let's talk about some issues. The first one is that lightning detector. That lightning detector is awesome, but it has that interrupt pin, which can be problematic. Most of the stuff in the embedded space tends to run single-threaded, and it's difficult to come up with how you write a single-threaded logic loop that is every 25 seconds, I want you to query all of these other nodes to get their information. But every time the lightning detector triggers something, I want you to not do that and then go get the information from the lightning detector and then go back to counting down until it gets complicated. So that was tricky. And GPS is also somewhat tricky because it turns out most of these people are throwing these inside of their house where it's hard to receive GPS. But we worked around that by cheating a little bit. Which is when the device comes up, it actually goes and hits an IP to geolocation service so that we have a broad idea of where the device is and they aren't all just showing up in the middle of the Atlantic Ocean. So what do we got working right now? I'll let you talk about a lot of this.
Inside of the IoT endpoints, as we talked about in the beginning, we're using Embed Linux OS, and it is in preview. It is not a final shipping product yet. So documentation and examples and code to draw from and learn from is pretty thin. So a lot of it has been very heavy research-driven, trial and error-driven development. It's a private GitHub repository, so there's not a lot of users in there interacting. Again, it's just early adopters that have access to it. So the point is it's been a slow process, but we have gotten to a point where container creation is well understood, and we now have the ability to interact with the I2C bus that was not working in the beginning.
Yeah, so the biggest problem we had right off the bat is Embed Linux OS. I think the thinking behind it, and I don't want to put words in the Embed's team's mouth, was they were thinking more for running application processing rather than being an IoT sensor. So the implementation was... it made total sense on paper. They basically just took the kernel and various other pieces from the Raspberry Pi ecosystem and brought that over. The problem becomes, by default, the device tree and the kernel for the Raspberry Pi do not enable I2C or SPI. So you can't talk to any external sensors except GPIO by default. And that all has to be enabled using device tree overlays. None of the infrastructure for device tree overlays existed inside of Embed Linux OS. And all of the documentation basically just copied the Raspberry Pi documentation and said, oh, just go update this config.txt file in the boot directory. The problem is that file is actually acted on by systemd, and there's scripts in Raspbian that do the device tree overlay stuff. So flipping those variables actually did nothing. Nope. So it took us about 3 weeks to figure out how to wedge all of those pieces back from Raspbian into the Embedded Linux OS so that we could at least see the I2C devices, which was a start. Yep. We opened up a bunch of bugs, reported this back. These things happen. It's okay. Yep. Pre-release software. And then after that, we started running into issues of about the time, just before that happened, Embed Linux bumped from version 2 to version 5. Core APIs changed, and all the work that I was doing writing against the C API no longer functioned because all the backend APIs changed. So we started going down the path of doing it in containers. Yep. Couple issues there. The biggest one was there is one piece of documentation that says you can now do work in containers. And that's pretty much it. So we've been spending a lot of time trying to figure out how to make those containers work, how to make them run, and then also people who have built container systems have never really thought of, I want to access I2C from inside of a container. So we had to deal with all of those problems again. Yeah,
Embed Linux is not using Docker. They're using Open Container Initiative. So these are OCI compliant containers, and that is really cool. But there's fewer examples and less documentation out there on the runC container runtime and the config.json that needs to be created to go with it. So again, it's just a much slower process.
Yeah. The edge nodes in the cloud server were substantially significantly easier to work with. So the biggest problem that we had right off of the bat is that I had, on paper, spec'd this all out to use the ELK stack. But you can't install ELK on ARM64. So scrapped all that, went with InfluxDB and Grafana. That worked much better. Influx actually provides all of that stuff. Influx and Grafana both provide packages for ARM64, so that was awesome. We're using the Linaro Debian build off of the HiKey 960. And then we're just running the Mosquito MQTT broker on there. So the idea is the IoT nodes would send MQTT messages to the edge nodes. The edge nodes would then reformat that into Influx queries and send it to the Influx database at our cloud server. And then we can distribute edge nodes wherever we need to, and it all shows up in a Grafana dashboard. All of that works except actually getting data to the MQTT node. That terminal window that we had a moment ago was David's Herculean efforts of the last few days of we now have a Docker container, or excuse me, a container that's running through runc that will actually pick up the data off of the sensors, and now we just need to shove that into a JSON object and send it off to the MQTT servers, and we should be able to pick it up. Yep. So hopefully we will actually have data on a chart by TechCon.
Yep, we're hoping.
So we talked a lot about the issues with Embed OS. Ecosystem challenges. This is your slide. I'll let you do this.
So, development, obviously, like we talked about, has been going much slower than we originally expected. I mean, we originally shipped out these boards about 4 months ago.
4 months ago, because the certs all expired after 3.
Yeah, so we thought this was going to be, a pretty quick, pretty standard build, but sure enough, here come the challenges. So one of the things that I'm really passionate about is that there's no standards compliant ARM desktop PC. You have a $35 Raspberry Pi device, and it's a wonderful device that can do a whole lot of things. You've also got a $5,000 to $10,000 Cavium Thunder X2 or Ampere eMAG, but there's not a whole lot in the middle of the market, and most developers do not have access to an ARM, PC-like device on their desktop. Certainly things can be built in the cloud, and you can run CI through Packet, but there are people that just want to have a device right in front of them.
So we did the vast majority of our development and work on these lovely Lenovo Yogas, and these are running Qualcomm Snapdragons, because the idea was ARM on ARM on ARM on ARM on ARM on ARM. See, I'm getting paid again. And then the problems became when we were trying to do the Embed stuff. So there's no Embed tooling for Windows ARM. There's Embed tooling for Windows x86, but there's no Embed tooling for Windows ARM. So then we were like, okay, great, let's just run it in WSL on Windows 10 on the machines. And that was fine, except the networking in WSL is weird, and you can't actually use the tools to talk to the devices. So then we were like, okay, let's grab another Raspberry Pi or an Odroid C2 and put all the tooling on that so that we can actually go poke at the machines and make it go. It's just been fun little things like that the whole time.
Hurdles everywhere.
And part of that was self-inflicted because we wanted to do this entirely in the ARM ecosystem.
Yep.
Some of that would have been easier if we were actually running from an x86 laptop.
Yeah, that is true. But, as proof of concept, I wanted to see if all of this could be done on ARM. And
we're stubborn.
Yeah, stubborn. So we just talked about this for a moment. The bulk of the work has been done on these yoga devices, which have worked really well for the most part. Like we said, there are some challenges, but
we only bricked them twice.
Yeah, but all in all, it's a really, really cool little machine. And if anyone wants to check it out afterwards, come on up or find us. It's pretty slick. And then if anyone is not familiar with the Arm Innovator Program, They are a team based out of Cambridge that helps people like us who try to honestly, see what works and what does not work in the ARM ecosystem. Develop and help us evangelize ARM technologies.
Yep. Yeah, they were great because that meant we didn't have to go buy a whole bunch of laptops and Raspberry Pis.
Yeah.
ARM did that for us,
Yep.
which was
ARM,
very sweet of them.
ARM has funded this project, absolutely.
So, Q&A. Anybody have anything? Yes. There's sweet.
I'll bring my mic over.
Thanks. Hi. I know Embed Linux does come with the connectivity stack to Pelion platform by default. Why have you chosen to use the MQTT and running MQTT server on an edge?
So the thinking there was we wanted to have a lightweight protocol to just move data back and forth. The idea was the Raspberry Pis are ridiculously overkill for being an IoT device. So if we were to do this again, we would probably use a microcontroller at that point, and having something where we don't have to have a really big network stack and we can make it run on something that's like a Cortex M0 or a Cortex M4 is going to be better. So using something lightweight like MQTT, that was the thinking there. Pass the messages that way, and then have the edge nodes, which have some more compute capability, translate them to what the cloud nodes are going to need.
So I think the Pelion client does work on Cortex M classes as well. So that could also the protocol is called lightweight M2M. So the clue is in the name. It's already quite lightweight. I think it could be a very viable option for you.
Cool. Something to look at. Other questions?
I hope. Yeah, this is on. Okay, good. So I'm listening to the conversation here, and you've dug into the details, the gory details, and solved a lot of the issues and going through and trying to make all this stuff, work together. My question is why did you choose Mbed Linux in the first place?
Excellent question. And the answer to that was because it was ARM. If we were to start this over again, we probably wouldn't use Embed. We've heard a lot of good things about Zephyr, and so we would probably be looking at that from a microcontroller's perspective, just because, again, availability of hardware. So the idea was we wanted to keep the bill of materials costs down since ARM was graciously sponsoring buying all the equipment. We didn't want to spend hundreds of dollars on every single sensor board that we were going to send out. But I know, for example, you can run Zephyr on Adafruit and SparkFun like $25 or $15 microcontrollers. So we probably would have done that. There are connectivity problems that we need to deal with there, but that's okay too. The other reason why we liked Embed is because it gives us the ability to push out firmware updates to devices that are already in the field. So while we were still debugging some of the software problems, we just got them all enrolled in Pelion and put them in the mail. And then when people got them, we could then push them a container update, which was great, until we discovered that you cannot push a certificate update, which was bad when all of our certificates expired 3 months later. But that's okay. That was a misunderstanding on our part and some missing documentation in Embed. It's no one's fault. It was just a misunderstanding. So that's kind of the reason why.
A second answer to that, I think, from my perspective, was a little bit more comfort knowing that it was running on Linux as opposed to an MCU or an RTOS or something like that. And that's only from a comfort perspective of my background, just being more of Debian-based or RHEL-based. I just thought, now wait a minute, Embed team is putting out a Linux variant. Let's not stray too far into uncharted territory for us. And so that was one of the reasons as well.
Yeah, starting with doing rapid prototyping in Python was going to be great. We quickly discovered that was actually going to be hard. And so at that point, there was really no difference between doing it on a microcontroller versus doing it on Raspbian doing it on a Raspberry Pi because we were doing it all I was doing it all in C, basically. So that's the answer to that. I think we have time for one more question, and then I think we're done. we're out of time. Anyone?
Yeah, so, Carl, real quick while you're passing the microphone.
Yes.
I think we ended up with did you get a 50-minute time slot?
I don't think so.
Or a 30?
Oh, so we have another 20 minutes. I'm sorry.
30 minutes, but
Sorry.
50, so we got 20 extra minutes somewhere.
So yeah, go for it. What's your question?
Okay, so my question is very simple. So I want to know some details about your difficulty to build the course, maybe course architecture images. You say it's difficult for you to build even on ARM platform, right? So can you?
Yeah, so it wasn't so much that it was difficult to build, is that it was difficult to deploy. So the Embed tooling, how that communicates with the end devices is using IPv6 link local addresses. So when you're running inside of WSL on Windows, there is a virtual router sitting in between WSL and the external network on your Windows device. And that prevents you from using the link local addresses. So that was part of it. The other issue is how these work is very clever in that there is an x86 just-in-time emulator for all of the Windows applications. So if you are running x86 code, not x86-64 code, but x86 code, it will just-in-time recompile that as you're running it to emulate it so that all of your traditional Windows apps work. The Embed Windows clients are only 64-bit, so we couldn't use them at all. So we had to go do something else. Running them on a different system that was running Linux, all those problems went away because we didn't have the router in between. In terms of making the actual payloads that we could deliver to the devices through Pelion or making containers, all of that worked in both WSL and in Windows and natively on an ARM64 system like a Raspbian or an Odroid without a problem. It was just the network communication between the Embed tooling and the actual devices where it got a little bit tricky inside of WSL. And that's just because of how WSL networking functions.
There is one other quirk that I found, and it's really not so much a quirk, I guess, as something that needs to be addressed on the ARM side from the Embed team. Actually compiling from source, building MBL, and then doing, your image creation and your MBL CLI and your MBL manifest tool and all of the artifacts that go along with developing in this environment. They don't build on ARM. I tried to compile them. They don't build. They fail. I opened up 2 or 3 GitHub issues saying, that's all great, but I don't want to use an x86 machine to literally build MBL.
So the issue there is actually, it's just a misunderstanding. I figured out what the issue was, and we opened up a bug and told them about it. Essentially, when you are building MBL, it has to build code for the target device, and it assumes it has to cross-compile. When we're building it on ARM and we're targeting for ARM, it goes, wait, I just built this and it came out as the same architecture as the host that I'm on. That's obviously wrong, and the build failed. Only it's not, because it's ARM going to ARM. So it was just a side effect of us doing some development on ARM. It was pretty easy to fix, like just commenting out that check, everything was fine. But it was just a minor oversight in that everyone who had ever used this has always been running it from an x86 host, so they didn't ever expect that the end device would also be the same architecture of the device that they were compiling from. So again, just minor little things, and it's not a big deal. It was just kind of entertaining when that came up, because I watched it happen and I was like, huh? And then dug through the code and I was like, oh, that's hysterical. Because I'm actually doing it all on ARM, it doesn't work. But not because it can't work, just because it thinks it's wrong. Other questions? Who's got a microphone?
If you revisit this again, would you think about using something like MicroPython or CircuitPython on your edge nodes?
So that was actually one of the things that I was originally looking at. The issue with doing MicroPython or CircuitPython is the ability to update devices in the field. That was the thing that I was most worried about, because we knew we were going to be doing iterative development on it, so we wanted to be able to get updates out there. There isn't a good story for that. So it would have taken more time to put together something to go check to see if the code needs to be updated and then figure out how to update it on the device rather than just using this. That was one of the things that Pelion fixed for us. It would be cool if something like that existed. I have not found it yet. So if you are aware of something, I'd love to know. But yes.
Okay. Well, if you think about the BBC Microbit, that runs MicroPython, but it's actually built on top of Embed OS. So
Yes.
actually, the bits should be out there.
And and the other part that's entertaining is the new Arduino systems are also built on top of Embed.
Yes.
And so we were all super excited because we're like, great, now all of the Arduino example code will work inside of Embed. Only no. There's an entire abstraction layer that sits in between it, and it is device specific, and that wasn't ported to the Raspberry Pi. So it's been fun stuff like that. A lot, like you see that stack and you're like, awesome, this solves problems, and then you're like, oh, actually no. So it's just working through some of the issues like that.
Yeah, we actually tried this a couple of years ago with MicroPython board, which had the Wi-Fi connectivity, but it didn't have the MQTT or the JSON token stuff that we needed.
Yeah.
And so we had an intern the entire summer trying to basically link that C code into the MicroPython thing.
Yep.
Didn't quite get there.
But see, that's a perfect example. It's much more difficult than at least I originally anticipated. I mean, you're talking about a full-time employee, I assume, if it was a summer internship, 40 hours a week, give or take. That's a significant undertaking. Yeah. So when I thought to myself, hey, Carl, this shouldn't be too hard. Let's build this out. I keep seeing people talk about it. I want to see it in action. Well, it turns out it's actually a lot harder than you think. So real quickly, what I have up here, actually, though, we hadn't really talked through, is so where is the node that was being passed around? Where's that endpoint? Okay, so that one clearly is not plugged in, but there's a second one that I brought along that is over in the 96 boards hacking room, which is Palm 5. And it is over there. It's an identical build as this one. And it's in there right now on the LAN in there. And it was one that I brought with me from Phoenix. So in its history, we can see that I was at lat long 33 -112, which was North Phoenix. And then I powered it down and drove across the desert 300 miles. And when I brought it back online just this morning, the GPS lock had updated, and that room is significantly cooler than my office temp. It was 82, and now we're down to 72. So it's live data. It's functioning. So now the next step is to get it out of that container to the edge. The edge is already pre-configured, ready to go. And then the edge will ship it to the cloud. Important to note that those temperatures are in American moon units and not in standard Earth units, so it is not on fire. So one of the keynote yesterday, there was a lot of talk about certificates and security, and that's what we need to do to all of these edge devices in order to make them more secure. That is actually one of the things that bit us very recently, is that we started seeing all of our devices fall off of the network in the Pelion device manager. And we're like, what's going on? And we try to reattach them, and it would just hang, and all sorts of weird problems. And we eventually discovered, David did some sleuthing and opened up some bugs. The certs that we originally initiated were 90 days.
I had assumed that we only needed a 90-day cert in order for it to initially connect to Pelion, and then it was going to do the whole cert renewal process once it was tapped in to continue functioning. Turns out that isn't the case, and the recommendation is, oh, just make a cert that has a 10-year lifespan, which is interesting, but has similar problems of, speaking for my day job, the biggest thing that I'm dealing with right now is buying hardware that's been sitting in a warehouse for 3 years. So that's something that I think, like, as a community, we need to spend a little bit more time focusing on is, like, having TLS certs is great, but we also need to make sure that we have a system for devices to be able to register and for those certificates to be able to be updated once they're out in the field, rather than it just being after a certain designated point of time, it just becomes a pile of planned obsolescence. Exactly, yes. So, you know, buy a new refrigerator.
Some governments aren't allowing
Right.
certs over a certain amount of time, or you have to make them revocable.
Yeah.
I was just saying that this, from PKI perspective, some governments or some regulators are preventing you from doing long-term certs. So
Yep.
you either have to, if you do a long-term, it has to be revocable.
Yeah, because a 10-year certificate may solve this particular problem, but it creates a whole different set of problems. That's not necessarily better.
Yeah. And any server that I made an SSL cert on 10 years ago is very compromised at this point. It doesn't matter that it had the cert or not.
Yeah, great job having a certificate, but
So yeah, something else to think about. Again, we've learned lots of interesting things, even though we don't yet have pretty pictures of lines dancing across a graph, but hopefully soon.
yeah, so if anybody wants to, pick our brains, yeah, we'll be here for another day and a half.
Yep.
We're mostly.
Yes.
We'll figure something out.
We'll figure it out. Yeah,
We'll
so
figure it out.
this is the hard part. Is like we actually have to be on the same layer 2 segment in order to update and put a new cert on it. But we'll get there.
I didn't even think, but that's an interesting talking point as well. So now we've got devices that are out in the field that cannot be remotely updated or containers pushed to them.
Yep.
Now, again, knowing full well that it's still, Embed Linux is still in a preview state, and if it gets resolved by the Embed team, fantastic, that's great. But the current tooling, the Embed CLI, or the MBL, Embed Linux CLI tool, does not have any methodology to update that remotely.
Yeah. Unless
I, from literally this yoga, am on the same network.
So invite David over for dinner and we'll fix it.
Yeah. But see, so that's a legitimate problem. That is a use case that is not addressed right now.
If you're coming to Austin, I can use my cert and we could do it there. So yeah.
He lives around the corner from you.
Sweet. So yeah, we'll get that taken care of. No problem.
Yeah.
And we got about 5 minutes left. Any other questions, comments, queries? Cool. We'll give you 5 minutes back so you can go enjoy the nice weather before your next session. Thanks for coming out, everybody. Appreciate it.
There you go.